Welcome to the video on summation notation. Let me get the title up here on the board. Summation notation. Maybe a new concept for you, maybe not. And so what is summation notation? Well, the best way is just to kind of illustrate it. So let me get the following expression up here. This is the Greek letter sigma, capital letter sigma, and this is our symbol for summing. And let's just say we have these symbols above and below it. This is a I equals 1. This is an n up here. And then over here we'll have a lowercase x with an I as a subscript. Let's just talk about what this means and define our actual pieces here. So let's look at this first piece here. I equals 1. What is this? This is called the index of summation. This I equals 1. The index of summation is essentially just the starting point for the lower limit summation. So where are you going to start at? That's all this is saying. You're going to start with the very first number in the data set. That's what I equals 1 means. And we're going to do a couple examples over here briefly to make sure that we completely understand this. Okay. What is the n up here? Well, the n is the stopping point. So if I equals 1 is the starting point for the lower limit summation, n is the stopping point for the upper limit summation. Put another way, all you're going to do is you're going to be summing from the first value through all n values in your data set. That is all this is saying. So let's look at this last piece here. Let's go to blue, I guess. And that is x sub I. What is x sub I? Well, x sub I is called the element here. You're summing across the elements. And the element is just the raw scores in your data set. Okay, so for whatever your variable is. So what is this going to kind of yield? What does this actually look like? So if we kind of just draw an arrow over here, all this means is you're going to be summing from the very first score in the data set through all n scores in the data set. So you're going to take the first x raw score, and then you're going to add it to the second x raw score, and you're going to add it to the third x raw score, and you're going to add that through all x, or through all n raw scores. You take the first raw score, add it to the second raw score, add it to the third raw score, and keep adding all those scores through n number of raw scores. So this is just kind of the written out version of what this equation, or what this expression, not equation, but what this expression is actually saying. Okay, so let's give an example here. So let's say we have a random variable x, and it produces raw scores for us that are 6, 4, 2, and 3. Those are our actual raw scores on this random variable x, whatever this is. It could be years of employment, age of your children, whatever it is, okay? And then what we want to do is kind of, well, let's just create a kind of a table here of what this might look like. All right, so let's go I. How many actual data points do we have here? We have 4. Okay, 1, 2, 3, 4. Extend this down a little bit. And then what is the actual x sub I value? Okay, so at I equals 1, when I equals 1, okay, that's right here, I equals, well, you can't see that, hold on. When I equals 1, you're right here at this value of 6. So the raw score, the x sub I equals 6. When you're at I equals 2, you're at the second raw score value in your data set, and it is 4. When you're at I equals 3, your value is 2, and when you're at I equals 4, you're at the fourth data point in raw score in your data set, and it is a 3. So let's kind of write this out long form. So it might look something like this. Sigma index of summation equals 1 through 4 scores of the raw scores equals 6 plus 4 plus 2 plus 3. 6 plus 4 is 10. 10 plus 2 is 12. 12 plus 3 equals 15. So when we write this over here, it essentially is trying to get us to this this value of 15 over here. Okay, let's give maybe just 1 or 2 more examples of other ways we might see this. Let's just show the variable x gives us a data set now of, let's say, -1, just to show you that we could have negative values here, a 3 and a 7. Make it real simple this time, 3 numbers. Okay, so let's do our I, and we have 3 levels here, 2, 3, and then our x sub I. So at I equals 1, we're at a -1. At I equals 2, we're at 3. And at I equals 3, we are at 7. Okay, so let's just show a couple of different ways that you might then see this kind of expression here change. Well, let's do it this way first. So let's say the sum from I equals 1 through 3 now of the xi raw scores equals -1 plus 3 plus 7. So -1 plus 3 is +2. +2 plus 7 equals 9. So the solution for this expression is 9. Well, let's just say you see it this way now. You see sum of I equals 1 through 3 of the xi squared. Well, what does this look like now? Now this means taking -1, squaring it, then adding it to +3 and squaring it, and then adding it to 7 and squaring it. So -1 squared is 1, plus 3 squared is 9, plus 7 squared is 49. 1 plus 9 is 10. 10 plus 49 equals 59. So again, just carrying this logic out, up here we just have, you're just summing the raw scores. Here you're summing the squared raw scores. And so in example 1, you're summing the raw scores. In example 2, you're summing the squared raw scores. Let's just show you one more way. Now this is, I'm doing all this because it's going to kind of be the precursor for understanding the equation for, well, simply sample mean, but then as we go into variance and standard deviation, you're going to see this kind of formula, and so I just want to make sure we understand summation of notation, or summation notation. So here might be a third example, or a third way you might see this. So sum of I equals 1 through 3 of the xi raw scores, and then take the whole expression and then square it. So what would this look like? So now you're going to do remember your order of operations, you're going to clear the parentheses first. So now what you want to do is go -1 plus 3 plus 7 squared equals order of operations. So -1 plus 3 is +2. +2 plus 7 is 9. So we've cleared the parentheses. That's 9, and 9 squared equals 81. So the solution to this expression is 81. So that is just a brief introduction to summation notation. Pay attention to what the element is and the upper and lower limits for summation, and I think this will be helpful for you when we get to the equations for mean and the equations for variance and standard deviation. Thanks for watching the video.